Yet again, I have another simple machine learning project where we are going to predict the quality of wine on the basis of parameters given as chlorides, sulfur dioxide, total sulfur dioxide density, pH, sulfates, alcohol. This is a simple machine learning project. Let's import this all. Read the data frame. It is a data frame with 1599 rows and 12 columns. Let's see if there is any duplicated column or row in this file. There are 240 rows which are duplicated in this data frame. So we are going to drop the duplicates by using drop duplicate. Our new data frame looks like this, where all the duplicated rows are deleted, with remaining with 1359 rows. The shape of this. Let's see the columns. These are the columns. And for the info, all are not null. Float, int. All is okay for this. Now our target column is quality, which is numerical for here. Predict the quality. That's all. Now let's see the correlation of quality with other columns. Correlation is like this. This is a correlation table. In figurative way, we can view the correlation in heat map. This is the heat map for correlation. Now we can split our data into input and output data. For this, we can run this where in our x variable, all the column beside quality is in the x variable, because all the columns beside quality is our input variable. Only the quality column is our output variable. So we are keeping all the columns beside quality in this x variable. Now we can split the data by using a simple method in sklearn. We can do it manually, but this time let's do it by using model. Run this. Okay, this is our train test split, which we import from sklearn.model selection. If we want to learn more about this, we can just shift tab and read about the documents given here. These are the parameters: arrays, test size, trend size. We can learn about this in this document here. Okay, the output, this simple code will be like this: x trend, x test, y trend, y test. These are the 4 outputs in the same sequence, so we have to take care of this sequence. 4 outputs as x trend, x test, y trend, and y test. Input linear regression, simple. Then we are going to fit our x trend data and y trend. First of all, we are going to fit, because we splitted the data. Test size. Test size is 0.2. It means that out of our 100% of data, 20% of the data will be of test size, and remaining 80% will be our trend data. Okay, trend data. If we have hundreds of data, then 20 data will be used for test purpose, and remaining 80% of data will be used for trend purpose. That's simple. X trend. Let's train our model. Done. Now we are going to predict using the x test data. 20% of data will be used for testing purpose. Prediction. Run. Let's run prediction. prediction. Here it is. This is the predicted data. Now we are going to create a compare graph data frame where we are going to compare actual quality and the quality predicted by our model. Simple. Now create a column by using prediction. Now let's see the tail value. Initially our quality was 4, our predicted quality was 5. 6 for 7, 5 for 5, 6 for 6, 6 for 5, 7 for 6. It's okay. Now using matrices we are going to see how much accurate or good is our model. We can import mean absolute error, mean squared error. You can use any of these. I'm going to use mean absolute error. Error is 0.5. We can compare mean absolute error with standard deviation given here, which is lower than standard deviation, so it can be right for now. For error MSE, mean squared error, we can do this, and this is root mean squared error. Here when I have normalized root mean squared error. For normalized root mean squared error, if its value is nearer to 0, then our model is quite good. Let's see what's the value. 0.15. It's quite good for now. Now let's calculate the error percentage. What's the error percentage for our model? Error percentage. Error percentage. 100 minus error percentage is accuracy. So our model is 98.6% accurate. So it's quite good. Furthermore, we can increase our model's accuracy by doing simple EDS, where we can neglect some columns from here which are not really necessary for us. And that's all.